Thank you for joining us today. My name is Tim Yeager, and I am in charge of the vertical markets at Tarana Wireless. And what we're going to talk about today is Tarana and the utilities market space. I am going to wait 1 or 2 more minutes just to make sure everybody has time to join, and then we'll get started. This is being recorded. If you have questions, please type them into the question box, and I will answer them at the end of the webinar. Thank you. Okay, so let's get started. So again, my name is Tim Yeager. I manage the vertical markets for Tarana Wireless here in North America. And today we're going to talk about Tarana and how it is being deployed in the utility market space. What we're going to cover today is some of the requirements of utility networks. Who is Tarana? Just a quick overview. What makes us different from traditional fixed wireless network providers out there? How Tarana addresses the requirements of the utility networks. A quick snapshot into what our roadmap looks like going forward. Examples of deployments and how to engage Tarana, and then we'll answer any questions. This will be a fairly brief webinar today, but we look forward to any questions that you have and diving in deeper on projects. So some of the requirements for utility-based networks are listed below. It is not an all-encompassing list, but we are seeing these common requirements coming up in just about all of the deployments that we're looking at. The radios have to be reliable and durable. Every outage that your customers or the utilities experience costs them money, whether it be soft costs or fines that are out there, and the radios have to be durable. They are being left into networks for much longer periods of time than regular commercial deployments due to the fact that the utility networks are basic critical infrastructure, so they stay in service almost around the clock. Ability to work in harsh conditions. We're going to be talking about networks that are deployed in some of the hardest conditions out there, environmentally speaking, whether it be cold weather, warm weather, humidity along the coast. So they have to be good, reliable radios that can work in any and almost all conditions. Ease of deployment. There are limited resources to manage and deploy these networks. So Tarana has decided to make the deployment on the remote node an easy experience, so you don't have to allocate a great deal of resources to manage these networks. Ability to manage remotely, access to multiple locations from a single location. The reason this is important is these networks cover large geographical areas, and by covering such large areas, it is hard to get to them to do diagnostic. So you need to be able to manage them remotely, and then when you dispatch somebody out in the field, they know what the issue is to take care of it, not just to diagnose. Increased need for more data. Applications are starting to demand more bandwidth. Remote monitoring is becoming common, and the demand for more bandwidth is definitely a part of these utility networks. Stuff that used to be monitored once a day, once an hour, is now being monitored every 5 seconds. Also, you have video surveillance starting to be deployed in a lot of these networks. So that uses an immense amount of bandwidth, and so you have to be able to support those bandwidth and the growth that is coming with this. Upload speed. Upload speed is just as important as download speed on utility networks and industrial networks. The reason for this is you are remote monitoring live equipment out there. So you have to be able to get that information back to a point where you can make decisions based upon what that information is giving you. And then security. Networks must be secure, both from attacks and then also due to some regulations out there on privacy. You need to make sure that these networks are secure from any kind of cyber attack. So who is Tarana? We are 14 years old. Most people started hearing from us back in October of 2021 when we started shipping this generation of product out there. We are a fiber quality fixed wireless broadband provider. We have well over 28 patents with more pending. Our current equipment is 5 gigahertz and 3 gigahertz of CBRS band. We call it G1, stands for Gigabit 1, not Generation 1, and has been designed from the ground up. There are traditional chipsets out there, 3G, PP, and Wi-Fi chipset, which are the majority of the fixed wireless broadband radios. What we are seeing with them is there's some inherent issues when you use those chipsets for broadband. So we decided that we were going to design from silicon up. We've ramped up from 2 deployments in October 2021 to well over 230 live networks out there passing real world network traffic, not just the pilots that we have going. We are designed in the US in the Bay Area, and we qualify for Made in America. So again, majority of the fixed wireless broadband that you see out there is either the 3G PP chipset or the Wi-Fi chipset. And we've decided with the flaws that come with using those chipsets in fixed wireless access, we decided we were going to build from ground up and have a broadband specific fixed wireless chipset to go. And we'll cover some of these issues that we're seeing with other networks that are out there. So 3GPP, it's the same chipset that you have in your cell phone. The easiest way to look at some of the issues that you would have with that is we've all been sitting at a venue where supposedly we have 5 bars, but we can't make a call or we can't send information off of our phone. The reason for that is the network's basically full. There's asymmetrical signal strength where the signal from the tower to the phone is much stronger than the phone to the tower. So you don't get the best performance with that. 3GPP relies on licensed spectrum. We have an unlicensed version and the CBRS version as well. There's minimal interference rejection. We can cancel up to 45 dB of our own interference and 40 dB of bursty interference from other radios and other networks on there. The downloads from the 3GPP are designed to come from the tower to the phone. It is designed as a download type of deployment and has unidirectional beamforming. We have bidirectional beamforming of up to 5,000 times per second. So that enables us to have much better reliability and much better performance in the network. We do have, again, symmetrical signal strength that enables high performance on both the uplink and downlink. So you are going to be able to get your information back up to the tower so you can process that. We have much better performance on number of subscribers supported per base node or node on the tower. And we have spectrum reuse of 1 as well, which means that we can use the same spectrum in all 360 degrees of our deployment. We don't have to alternate parts of the spectrum to use. So I have a customer that reminds me every time that I talk to them that it doesn't matter what our radios do in the lab, it's real world performance that is key. And on the left, we have some of the big issues that we see out there in real world deployments: obstructions, interference, low throughput or capacity, poor link reliability, congestion, and just can't deploy quick enough. So with obstructions, Tarana embraces multipath and reflection. So we work much better in near line of sight and non-line of sights out there, where traditional fixed wireless was just line of sight. So by using reflection and using multipathing, we have intelligence on both ends of the link, so we can make the necessary calculations to get that bandwidth in phase, so it adds more reliability, more distance, and more throughput to our deployments. Unlicensed interference, we talked about that a little bit previously. We have the ability to cancel interference, whether it's from our own radios or whether it's from other networks that are out there. By putting the lobe towards that interference source, it literally will cancel out that interference source. We have the ability to do high capacity on our base nodes. Right now, on deployments, I think the largest number of subscribers we have per base node is well over 182, and growing up to the maximum that we can do is 256 on there. Again, with the port link reliability, with us being able to use multipath and reflection, we are able to make connections that other fixed wireless access providers can't make at all. Channel congestion, again, this all comes to, with us being able to use the channel reuse of 1, we use less of the channels out there, so you have more to choose from when you are deploying. Roadmap. So this is just a snapshot of some of the stuff that's coming up. I'm sure a lot of you have heard of 802.11ax that's out there. That's being used with Wi-Fi 6 and then also 6 gigahertz deployments. So to separate a little bit of this out there, 802.11ax deployments take 160 megahertz of spectrum, all continuous. The problem with that is there's not really very many places in the US or North America where you have 160 megahertz of uninterrupted spectrum. Currently, with our G1 product, we use 80 megahertz of spectrum, but it does not have to be continuous. You could use 240 megahertz channels. That is also going to continue with our next generation of product, where we are going to be increasing the throughput up to 1.6 gigabits per second. in both the 5 and 6 gigahertz spectrum combined, and that will encompass 4 40 megahertz channels. Again, does not have to be continuous, they're independent channels. And that will also be field upgradable to existing remote nodes that we have out there now. The base nodes will be specific 5 gigahertz or 6 gigahertz. And you can expect to see these products by the end of the year this year. Deployment examples. So these are real world deployments, and they're not all of the utility use cases that we have out there. There are just some of them. Some of our partners are using this in other ways as well. This one is a utility wanted to upgrade their infrastructure. They wanted to add video surveillance to their existing SCADA network. SCADA network was serial. They wanted to upgrade it to Ethernet and incorporate the video surveillance. They originally were looking at doing fiber to all of their locations, and due to budget and time frame, it was not feasible for either one, via time frame or budget. They went and looked at Tarana. Tarana was deployed. We were able to come in under budget for them and able to deploy within 6 months of the time of start of deployment. And so we came in under time schedule as well for them, timelines. So we are also seeing a lot of utilities now starting to offer or continue offering broadband service and expanding that offering as well. They have the assets out there in the market, and so they're starting to offer, become an ISP. It also generates additional income to the group as well. So Tarana was originally built for fixed wireless access with the broadband in mind. So they're deploying Tarana to service this market and then utilizing some of that infrastructure for their own needs as well when they're having to hit their own internal network as well. This was a deployment here in Colorado where a local utility had a customer who owned a number of commercial and industrial buildings, and as a joint partnership to reduce some of the utilities that were being used, they deployed a state-of-the-art HVAC system, access control system, sensor network, and video surveillance in all of the buildings. And as part of that, to hit the bandwidth needs, because all the locations couldn't necessarily get the throughput and the bandwidth that they needed to handle all of this traffic, a private fixed wireless network was deployed through these buildings. It gave the building owner the ability to basically offer smart building services to their tenants, but it got big control of the costs on the network for both the utility and the operator of these buildings as well. So again, this has been a very brief overview of the utility marketplace. We can't talk about all the case studies because of the nature of them, and some of them are private. But reach out to your Winncom account executive to engage us. We would be more than happy to work with any of your customers or yourselves with Winncom and discuss some of the needs that you guys are having. If you have any questions, now's the time to start typing those in, and I'll start to address those as we come through these. One of the questions that has come through deals with other power generation areas such as wind and solar. We do have deployments in both those, mostly monitoring on the wind turbine side, it's vibration sensors. On the solar side, it is more making sure that the solar panels are operating to peak efficiency, and if they have to turn, they are turning with the sun as well. Are there any other questions that anybody has out there? So I did see a comment in there that the audio is echoey. I am sorry. I will get with Winncom and I can re-record this and see if we can help with the audio side of things with that as well. So I don't see any other questions at this point in time. Again, thank you very much for your time. Please reach out to your Winncom account executives, and they can help you and engage the right people within Tarana. Thank you for your time today.